All right, folks, so one of the things we kind of mentioned that we'd try to do for you here in large group when we went through this quiz on Friday was to come back later on now and go through the answers, sort of talk about some of the most common mistakes, maybe why those might have happened. And so I kind of want to do that with you here, just briefly kind of go through the questions. Some of them are rather fast and simple to explain. Others may have a little more detail. Number one, this is one of several questions in this quiz that ask what type of reaction this is. This is a synthesis reaction, so your answer should have been A. As you're looking for the reason why this might be, there's really no other way to take these two elements and have them react together other than to put them together into something bigger. They can't decompose because typically a decomposition reaction will have just one reactant turning into many things, two or more things. A double replacement reaction would require two compounds, which we don't have here. And combustion would need a fuel with oxygen, which we don't have here. So synthesis is the only choice. Number two, cobalt sulfate decomposing will give off a metal oxide and a non-metal oxide. Well, here we see we've already been given the non-metal oxide in sulfur trioxide. The other compound then needs to be a metal oxide. And that metal here is cobalt. The only cobalt oxide that's listed on the choices here is letter D. It's important to notice that the Roman numeral 2 is also part of that name because cobalt still keeps its same +2 charge that it has in the beginning compound as well. So cobalt 2 sulfate becomes cobalt 2 oxide and sulfur trioxide. And number three, this is a decomposition reaction, one thing reacting to produce, as any of these choices will give you two different things. And as with most acids, we can predict them to decompose to produce water and a non-metal oxide. The only question left then is, which non-metal oxide? Both A and C could give you the correct answer here. In sulfuric acid, you want to identify sulfur as having an oxidation number of +6. The way you do that is to think about hydrogen always being +1 and oxygen always being -2, almost always. So when you put those into the compound, the hydrogens are contributing +2, and the oxygens are contributing a -8 to the overall oxidation number total. Now, because this compound needs to come out neutral, the sulfur needs to contribute the other +6. So the two hydrogens would contribute a total of +2, the sulfur would contribute a +6, and then the oxygens contribute the -8 that makes the compound neutral. If sulfur has a +6 oxidation number, the way that works with oxygen then would be to make SO3. +6 and -2 on those elements give us SO3 as a neutral compound. So A is my choice here. In C, the other option, sulfur has a +4 charge. That's not what we start out with at the beginning. Number four, manganese and chlorine will combine to produce what? Well, manganese chloride certainly, but what is it? Manganese 2, manganese 4, manganese 7. All of those are options for manganese. If you look at the periodic table, manganese takes on many oxidation numbers, including 2, 4, and 7. What you wouldn't want to do is simply say manganese chloride without a Roman numeral, because that's not appropriate. We need to know what the oxidation number you're designating on it would be. And so you might choose 2 or 4 or 7. You might also choose, I think, 3 or 6 are choices for manganese. And so just specify which one you're using. Any of those would be correct. Manganese chloride isn't specific enough. Number 5, lithium hydroxide and magnesium carbonate. What type of reaction will this be? Well, there again, synthesis. Well, putting all those together into one big compound seems like a really big, beastly, impossible to name sort of compound. And typically, at least in first year chemistry, we're expecting that whatever products we come up with, you should be able to come up with a name for. Well, if I put those together, I don't know what the heck I'd call it. So I'm going to assume that I can't name that, and that can't be a synthesis reaction. Decomposition, typically you won't have two compounds or two substances starting out your reaction for a decomp reaction. So it can't be decomposition. And let's rule out combustion because there's no fuel here. So without a fuel and oxygen, you can't have a combustion reaction. That leaves double replacement. And of course, these are both cation, anion compounds, where the lithium and the magnesium are cations, the hydroxide and the carbonate are anions, and in a double replacement reaction, potentially, those two would just switch partners. And we'll see what we get out the other side of that reaction afterwards. So that's a double replacement reaction, letter C. Number 6, which substance would be the precipitate? So we're assuming that one of our products would be the precipitate. Remember, when we're looking at a double replacement reaction, we're looking for a reaction. And usually the presence of a new precipitate is how we know that a reaction has occurred. So really, we're asking which of the products is a precipitate. Remember, you shouldn't expect to find a precipitate in the reactant side. Both of those typically are soluble salts that are designed to dissolve into solution here and be used to mix with each other. So if we look at barium oxalate and potassium nitrate, You can look at a solubility rule set, or you can look at a solubility table. Either way, you'll find generally potassium compounds are all soluble, and nearly all nitrates are shown as soluble as well. So potassium nitrate will be soluble and therefore not a precipitate. The only other choice is the product barium oxalate right next to it there, and that's choice letter C. Barium oxalate, you can look it up, is fairly insoluble on both the barium side and the oxalate side. Barium oxalate is an insoluble compound. So the choice as my precipitate would be that solid barium oxalate, letter C. Number 7, strontium oxide and water will combine to form what? Well, this is again knowing what synthesis reaction sort of templates we've looked at. This is a metal oxide combining with water. And if you think back or look back, recall what we did with metal oxides and water joining together, they make a base or a hydroxide compound. So the hydroxide here has that OH ion in its formula. We find that in letter A, we find that in letter C, we kind of see that in letter D, but really what's the appropriate formula here? Strontium hydroxide. Well, remember strontium in a compound tends to take on a +2 oxidation number, and hydroxide ion has a -1 oxidation number charge. And so when strontium and hydroxide get together, you'll need 1 strontium and 2 hydroxides to make that compound work out in terms of overall charge. So strontium hydroxide is the answer, and the formula for that is most appropriately letter A. Number 8, 8's a little tricky one, probably the first tricky one of the bunch on this quiz in general. It asks, in the reaction above, the bromine in the missing product would have an oxidation number of what? Well, remember, in most of the compounds that we're introducing you to here in first year chemistry, whatever the oxidation number is on the element like bromine here at the beginning is the same oxidation number it'll have at the end. So what does that mean for us? Well, figure out what the bromine's oxidation number is in the original compound here, HBRO, and you should be able to carry that oxidation number across to the other side of the compound, or either to the other side of the equation, and then your other compound that's produced. Well, what is the charge on HBRO here? What's the charge on the bromine? Hydrogen, typically a +1. It is here. This is an acid. We'd call it hypobromous acid. The hydrogen has a +1 charge. The oxygen, typically in compounds, takes on that -2 as an oxidation number. Well, if hydrogen is +1 and oxygen is -2, that bromine, in order to make things come out as neutral, the bromine will need to take on a charge of +1. So hydrogen's +1, bromine's +1, and oxygen's -2, and that makes HBRO neutral in terms of electrons. So that bromine's +1 oxidation number would also be found on the other side in the compound that's missing in the blank. You'd need to put that with oxygen in order to figure out what that's going to be and determine the product of that formula over there, or the formula of that product rather over there. But it's going to have a +1 oxidation number, so A is my answer for 8. Number 9, this looks like a double replacement reaction to me. Putting those partners back together again on the other side of the equation, how's that going to look? The only real trick to this one, well, I want to eliminate C because 2 things aren't going to turn into 4 things by any of the reactions that we've been doing so far. But A, B, and D sort of all suggest to me the possibility of a double replacement reaction. So which one's correct? Well, if you remember the charges on these elements, manganese in this compound has a +2 charge because it takes 2 nitrates to go with it. So manganese is a +2 and nitrate's a -1. In the other compound, sodium's a +1 and hydroxide's a -1. So if I put those together and make them into 2 new compounds, the manganese is going to keep its +2 charge. The others will be -1, +1, and -1, just like their charges were at the beginning. When manganese recombines and forms a compound with hydroxide, the manganese with a +2 and the hydroxide with a -1 charge will have to combine in such a way that there are 2 hydroxides for every manganese. And the only choice where we see 2 hydroxides for every manganese is in letter D. The other detail that's there is the state symbol where it shows the manganese hydroxide as a precipitate or as a solid. You can look up its solubility and find that that's true too. In the end, the formula is what makes it the final choice, letter D, where manganese hydroxide's formula is the key. And number 10, what type of reaction is this? Well, this is a combustion reaction. We're burning sugar. This is literally the formula for sucrose, which is what the sugar might be you'd find in your house for baking cookies or something. We've taken that sugar, combined it with oxygen. We assume it's being heated, and then that'll eventually, potentially, burn. You can burn sugar. So sugar plus oxygen is a combustion reaction just like any other fuel with oxygen. On number 11, What is the formula for the second product? Well, what have we got left? We've taken calcium carbonate and hydrochloric acid, which is essentially hydrogen and chloride in ion form, and we've formed calcium chloride. Well, what's left? We should have the other cation there, which is, in this case, the hydrogen ion, and the other anion, the other negative half, which is missing, that's a carbonate. If we put hydrogen with carbonate, we get carbonic acid, and that's shown as letter C. So in this double replacement reaction, carbonic acid would be the other product. Now you might remember Mr. Mitchell introduced in large group how carbonic acid is very quick to fall apart itself, to decompose immediately afterwards and produce water and carbon dioxide. But the immediate second product of this double replacement reaction, at least for a moment, is carbonic acid, letter C, before it falls apart and produces other things. Number 12, we've got a double replacement reaction here again. Sodium iodide is combining with sulfuric acid. And the two products, that will be the combinations of those two things reversed. Sodium will go with sulfate. So right away I'm looking at my choices and I'm thinking, well, that's got to be either A or B, and you'd be correct. And the other one will be hydrogen with iodide. Well, both A and B have hydrogen with iodide in them, but which one's the correct formula? Again, hydrogen takes on a +1 charge as always, nearly always. Iodine, when it's in the negative side of a compound or an acid, takes on a -1 charge. So hydrogen +1, iodide -1 means the formula will be HI, which is seen there in choice B. So sodium sulfate and hydrogen iodide is choice B. Which of the following compounds is likely to decompose and form a metal oxide? Well, first of all, in order to have a metal oxide, we have to have a metal, right? And if I look at A, I don't see a metal there. Boron's a metalloid. If I look at D, I see silicon, which is a metalloid as well. So immediately I can throw out A and D. I'm left then with two choices, B and C. Which of these will decompose to form a metal oxide? Well, there's two ways to think about this. If you think back to the examples we've done, you'll know that hydroxides, like letter C, lithium hydroxide, will decompose to produce a metal oxide, lithium oxide, as well as water. So lithium hydroxide will in fact decompose and form a metal oxide. So C is the answer here according to that. You could also look at letter B and say, well, heck, that's already a metal oxide. So if it decomposes, I'm not going to have a metal oxide. I'm going to have a metal, magnesium here, and oxygen. So the only one that can decompose and give me a metal oxide afterwards is the one that has a metal, that would be B or C, and isn't already an oxide, which is C. So the only choice you really got here is C. Number 14, we're taking calcium oxide and carbon dioxide and putting those together. This is a classic example of how we make a ternary salt. Calcium oxide and carbon dioxide coming together to make calcium carbonate. Now, how do I know what the formula is or what the name is for that? Think back to what we thought about earlier with the sulfate ion in that sulfuric acid question toward the beginning. What you need to do is think about what is carbon's oxidation number in carbon dioxide. Well, oxygen tends to be -2. And if I've got two of them in my carbon dioxide, then the overall positive charge on the carbon would have to be 4+ in order to make that compound neutral. So carbon is 4+ and oxygen is 2-, and that gives me carbon dioxide's overall formula. Well, if I bring that carbon with a +4 across to the other side of the formula of the equation, it's going to show up in a compound where its oxidation number is still 4+. Now, if I go through my two choices here, which are B and C, calcium, carbon, and oxygen combined into one compound, the only one of those where carbon has a +4 oxidation number is letter C. Calcium is +2 as an oxidation number. Carbon's +4, so that gives me a total of +6 on the positive side. The oxygens, 3 of them, give me -6. So in letter C, carbon's charge or oxidation number remains a +4, and that makes it the correct choice since that's where carbon starts, at a +4 in that carbon dioxide molecule. So remember this theme that the oxidation numbers tend to stay the same from one side to the other in many synthesis and decomposition reactions.